Okay, this problem is related to hydrolysis of ester. So let us copy this one. So here I have oxygen that is labeled. So this is oxygen 18. In some books they simply write a star. So I can write the same molecule something like this, PHC double bond O. And here I have oxygen that is a labeled oxygen. This is not oxygen 16, this is oxygen 18. So let us make a star here so that one can understand this oxygen is a different oxygen. So this oxygen and this oxygen are different oxygen. Now the first part of the question says, draw the mechanism for saponification of this ester. Use this mechanism to show where the labeled oxygen will appear in the product. So you have to also show whether the labeled oxygen will go after the reaction. You have to write down the mechanism of saponification. So first part, so you have to write mechanism for saponification. What is saponification? Saponification is basically hydrolysis of ester in basic medium. So in basic medium, if you do hydrolysis, that is in the presence of OH minus, we call it saponification. So I think all of you can write this mechanism, PHCO O, and here I have CH3. Now this oxygen is a labeled oxygen, and then if I have OH minus. Now what this OH minus can do in the first step? Okay, let me wait for 1 minute. All of you can do this one. So let us do this one fast, and this is the only way to learn. If I am simply doing and you are simply copying, there is no development of mind. You have to do also yourself. So let us do this one. Okay, let us do. So now this lone pair can attack. So this will act as a nucleophile. This attacks here, and this goes here. So there is a two lone pair initially also have. So I will have PHCO minus. So I am showing you the lone pair also. And this side I have OCH3. So let us write CH3 as Me. And now this oxygen is basically labeled oxygen, so let us label this oxygen. And now here I have OH. Now what should I do in the next step? Now this is a leaving group, so I have to repel this leaving group. So what happens? So this comes here and this bond goes here. So that is, I am repelling OMe. OMe is a good leaving group. So what will happen? So you will have, this side will have PHCOOH. So PH C double bond OOH, and this side will have MEO minus, and this oxygen will be labeled. So the oxygen that is labeled basically attached to the Me. So MEO minus, and this oxygen is labeled oxygen. Now this minus can take H plus from here, so it will form MEOH. Are you getting? So this minus can take H plus from here, and this can go here, so you will get a carboxylic acid salt. So you follow these steps, so you will have PH C double bond O minus, that is a salt of carboxylic acid, and this side you will have MEOH. Now this is the oxygen that is the labeled oxygen. So question is asking where the labeled oxygen goes. So I can say the labeled oxygen goes to the alcohol. Are you getting? So labeled alcohol is now in the form of alcohol. Now the B part of the question says, draw the same mechanism in the presence of acid. So let us write mechanism of the same reaction in the presence of acid. So you have to write in the presence of acid. I am waiting for your answer. This oxygen is a labeled oxygen. Now this time I will have H plus and H2O is there. Okay, let me discuss. So what will happen? This H plus will act as a catalyst. Now this H plus will go here. So in the first step, this is a catalyzing of this group. So you will have, I'm writing here, so this will give you PHC double bond OH. Now there will be a formal charge on this oxygen, and then you will have O, Me. Of course, this oxygen is leveled oxygen. Now what will happen in the next step? Now this carbon has a slightly positive charge. So in the next step, H2O molecule will attack here. So let me attack of H2O. So I have OH. So H2O molecule will attack. This goes here. So you can write the same thing. And in the same step, I can lose H plus from water. So I can write pH. If you want, you can write a detailed step, that is, in the one step you attack one, and then in the next step you lose H plus. I am doing in the one step so that things becomes fast. PHOH, CHOH, and then I have CO, and this is leveled oxygen, and then I have Me group. Now everybody knows two OH on the same carbon is not stable, so what I have to do is this goes here, and I have to leave this leaving group. So I will get PHCOOH, OH, and then I will get MEO minus, and this O minus will be basically radioactive oxygen, that is the leveled oxygen. So you will have MEO minus. Now this O minus, the medium is acidic, so this O minus can take H plus. So Me, that is the salt of alcohol, will form alcohol itself. So you will have PHCOOH plus alcohol, that is in this case MEOH. So you have MEO star. So you will have MEOH. So you will have one product MEOH. So you see, medium is either acidic or basic. The product is same. The O star, the radioactive leveled oxygen, goes with alcohol in both cases. Now only thing is, in the basic medium you will get the salt of alcohol, and in acidic medium the salt of alcohol you will not get, because this will get acidified. That is the only difference we have. Otherwise we don't have any difference in both cases. And one important another point is, basic hydrolysis is called saponification, and acidic hydrolysis is basically reverse of esterification. You getting? So if you go from this side, so acid plus alcohol, that is called esterification in acidic medium. This is the reverse of. So in acidic medium the hydrolysis is reverse of esterification. Basic medium is called saponification, because this is the compound that forms. So salts are used to form soap. So these are the salts that is used to form soap, and that's why this reaction is called saponification. You're getting it? So these are the carboxylic acid salts is used to form soap. That's why this reaction is called saponification. It is not called soponification, it's called saponification. That is also important. We'll discuss the next problem.